Hello everyone and welcome back to my class. I'm Engineer Bakri and it's a pleasure to have you here today. In this lesson, we will be exploring sign convention in heat and work. So grab your notebook, relax and let's dive right into learning something new and exciting. In thermodynamics, sign convention are used to indicate the direction of energy transfer between a system and its surroundings. Energy crosses the boundary of a system in the form of heat or work. The sign convention helps to maintain consistency when applying the first law of thermodynamics. The first law of thermodynamics is expressed as change in internal energy of the system, Q minus W, where change in U is the internal energy of the system, Q is the heat transfer or rejected in the system, where change in U is defined as change in internal energy of the system. Q is defined as the heat transfer and W is defined as the work transfer. Now we are going to look at the sign convention for heat. Thereafter, then we'll go back to that of work. Now let's consider a system whereby we have, this is a system and everything around the system is known as the surrounding. Q positive, and this is taken as Q negative. W negative and W positive. Q positive simply means heat is added. It's added to the system from the surrounding, or in another synonyms form, it can also be referred to as heat input into the system or heat supply to the system. While Q negative is defined as heat loss from the system to the surroundings. Now let's take an example of heat added to the system. If you have a water in a pot and the pot is placed on hot plate or a gas burner, the gas burner is the one supplying heat into the system of the cup. Then similarly, when you have a cup whereby you have a hot coffee which is about 90 degrees centigrade, when it is being exposed to the atmosphere, there comes a loss of heat, which means the temperature of the tea drops gradually. So in such case, heat is being removed from the system. It can also be said as heat loss from the system to the surroundings. Now let's go back to work. In such case, what happens to the internal energy of the system when it is added to the system? The internal energy of the system tends to increases. When it is added to the system, the internal energy U tends to increase, and when it is lost from the system to the surroundings, change in U tends to decreases to zero. The first one, change in U is greater than zero. When internal energy is greater than zero, it simply means that it is added to the system. And when internal energy is less than zero, it simply means that it is lost to the system. Sign convention for work. The sign convention for work is what we are about to do now. Let's refer to the figure above. When work is done from the surrounding to the system, it is taken as negative. This shows that work is done from the surrounding to the system. The positive form shows that work is done by the system to the surroundings. In the positive form, the internal energy is greater than zero. The positive forms of W shows that change in internal energy is greater than zero. It means that change in internal energy increases in the system. While the negative form of W indicates that change in internal energy is less than zero. Now let's look at a practical example. Let's consider a piston cylinder arrangement. This is the piston, this is the cylinder wall, this is the piston, this is the connecting rod. Once the gas in the system expands, what happens to Q and W? Q in this case is greater than zero. And the piston, as it is being forced outward, shows that work done is greater than zero as well. And similarly, when Q is less than zero and W is less than zero, which means the cylinder comes back to the normal state. That is, it compresses back to the normal state. I believe you all understand the sign convention in it and work. If you have any question on this, drop it in the comment section. Like, share, comment, and subscribe.